I probably have this design your hypothetical experiment not in the best place because you guys just worked on creating your own surveys and working on a correlation. And then I have you design an experiment and I ask you to talk about how you would kind of statistically look at it. And so you have this idea of correlation fresh in your mind, and then you use that in the experiment. And then next we go on to what basic statistics you need to know, and we talk about statistically significant. So you haven't really done that yet. And in a way, I'm doing this because I want you to intuitively understand what's happening in an experiment before you get lost in the statistics of it. So when we have a correlation, this part, right, we can have a positive correlation or a negative correlation or no correlation. The big thing is what we're not doing is there is no manipulation of your groups. You might have different groups, of your groups. So you might have two natural groups. So one student was talking about age and TV time, right? So as age gets higher, this would be a negative correlation, right? As age gets higher, does how much time they spend watching TV go down? And that is a correlational study because you're not manipulating the groups. You're not, you can't change somebody's age. So you're simply looking at this. So be careful of this as you're doing your experiment. I'm not asking you to design something that's looking at it, correlation. I want you, in a true experiment, what we're doing is we're manipulating one group and the other. So we have to say we're creating some sort of condition by which we can change that condition, and then we can see, does that change in the conditions, in the grouping, does that cause a change in what we're measuring? So does the independent variable cause a change and the dependent variable? And you're going to look at statistics starting tomorrow and into next week, but let's just think about this without thinking about any math, because what we're really asking is, let's say this blue line here, what do we want to measure? So let's say, what are our two groups going to be? So let's say group one, what do I want to measure here? Let's say in group one, they have a tutor. So group one gets a tutor for math. And group two gets no tutor, right? Maybe group two is told how to, so we can have three groups. Group two gets no tutor, but they're gonna get help on Googling videos. Although I don't have a third chart here. And group three gets nothing, right? They get no additional help. And then, so that's my independent variable, right? How I'm grouping them. My dependent variable is gonna be what I'm measuring. So that's really what I'm showing here on the chart. And so I'm measuring test scores, right? And we could say that we're not going to have everybody have the same test score, right? There's going to be different test scores. And I would need to put, can I draw, let me see, can I draw another shape on here? Doesn't just let me draw. We're going to have to imagine that there's another, we're going to do another curve here, right? And this curve is going to be for group one. So I would draw another curve up here, and I would see that the test scores were higher for my group getting the tutor. Let's say the middle was the group I taught to Google, and the bottom here was nothing. So these are their test scores down here. And this shows the distribution of those different things, right? So how many people, so in this group, let's say this group two was the red group. So they're getting, like, their average score here would be a 50. So let's say our tests are really hard, right? And the average score for group three getting nothing was a 25. And the tutor, let's say they're up here, so the peak is at 80. So the average for the tutor group was an 80. Well, could those groups be different just by chance? Like, could we have these scores be different just by chance alone? And the answer is yes. Probably not as different as we're seeing in this picture here. And that's where we get to what statistically significant means. You'll see it next week. But what I'm trying to get you to do on this experiment is just say, well, I'm measuring a dependent variable, and group one is different than group two. So I want to show that that difference is meaningful. All right, and you can do that without knowing anything about statistical significance. Just be careful when you're designing your experiment that you're not designing a correlational experiment because you just learned about it. And if this is confusing, make sure to write me. I'm here to help you.